Hello. Especially hello to Ivan Safonov and Yegor Gorbachev, but actually hello to all viewers. Today we are solving Misha short contest 2. And I shall register for it now. Let's open OEs. And let's open GitHub. Yeah, let's go. Actually, we will need to look at all problems because I think maybe the first one might be not the easiest one. So the first one we have an undirected graph. Simple. The country will be divided into R states, vertex-wise. So we have inner roads and outer roads. Each city should have even numbers of inner roads. How it's said in Russian. There is no Russian version of this problem. Okay. So we want to find the minimum number R such that you can divide the city into parts. In each of them there is even number of inner roads. Okay, this is interesting. Let's solve it for a bit, and if it's a hard problem, we look at other problems. So the easiest way is to consider each vertex as its own state, but this leads to quite a big number R. Also, if the total number of edges is even, then you can just take R equals 1 and the whole country is a single state. So we're now considering the case when it is odd. Okay. Can we consider one vertex and remove it? It only and only it. If the number of edges here is odd, then we are happy. If it is odd, then we are happy because the number of edges here is definitely even. So the sad situation is all degrees are even. So it's an even degree graph. Okay, maybe we can take two vertices. So for two vertices, this thing is 1. Also, there are even number of such edges and even number of such edges. And this means that the total number of edges is inner edges of this type plus this, plus this, plus this. And since the total number is odd, then it is odd. So this is quite an easy problem. Let's solve it. we have n and m. Several test cases of, okay. So what is the answer? The answer is, it's the proper division. So instead of that, we should return VVI. So here we provide the graph, which is n and the list of edges. Okay. What? How? N space separated numbers, so it should be VI instead of VVI. It's fine. Great. So now we just need to return this answer. To do that, we simply, first of all, we need to find the number of edges. Like this. If e dot size is even, then we return VIN. Okay. No, we need to return pair int VI. And here we return 1 and VIN. Actually, we can return minimum of 1 and n in VI, because it makes sense. Great. So here we need to say that auto r and ans equals find ans, then this. Yeah. So here, what do? We need to find any vertex with an odd number of edge, with odd degree. So now we look for an odd degree. So if deg I %2 equals not 0, then we return the answer. How do? We say that v ans is n, then we say that ans I equals 1 and return 2 ans. Finally, if it is not the case, we just look at any edge and do it. So we say ans e.front.x equals 1, .y equals 1, and again return to ones. Let's try. 1 and a lot of ones. What? There is even number of rods, odd number of rods. Why did it think? I don't understand. Why is it correct? I want to split to be done in such a way that each city would have even number of each city. So each degree is even. Oh my god. Why am I so careless? Okay, let's think more about it. So if we have some, if all vertices have even degrees, then we are fine. Problem is we can have some vertices with odd degrees. We would like to divide it into two parts. Let's look at it. We have two parts. Here all degrees are even, and here all degrees are also even. Let's think in terms of matrices. So we want to divide the matrix, adjacency matrix, into several parts, such that in each part the sum is even. So the sum is 0. What is it like? It's like, so I have some matrix A, yeah, and I want to consider such array V, yeah, so I want V, so that if I take what do I take? So consider that, for example, let's assume that I only took first I columns, which corresponds to this vector. Okay, in this case, I want the sum of these rows to be 0. What are these rows actually? First of all, I want construct so I want to sum up these elements and these elements, etc. So it is like A times this array V. Okay. No, it's like V transpose times A, I believe. So we can multiply it like this. Mm-hmm. So we get, and we want it so that it is a subset of V. This is what we want. Not only is it a subset of V, it should be that if I multiply it by V, it is 0 in integer numbers, not in residues modulo 2. How it's done? So again, I have a matrix. I have some vector V, and I want to sum these rows, and it should be 0, and sum these rows, and this should be 0. How can I do it? Is it multiplication of matrices at all, or not? Yeah, I think it is not, because I cannot remove this part at all. It is impossible. Well, it is not really impossible, because I can sum up this. I can sum this up. Yeah? How can I sum this up? Okay, the problem is, if I have some matrix, and I want to only consider this part, is it possible or not? Not really, because if I want to zero this, then I need to multiply it. But in this case, I will have all these columns, and I'll have to sum them up somehow. Okay, this is not a multiplication of matrices problem, but still, what do I do? Is there some sort of lower bound? For example, if I have a complete graph, if it is of odd power, then it is of even number of vertices, and I divide it into two graphs of odd number of vertices. So this should be easy in case of odd. Okay, if all degrees are odd, can I do something? If all degrees are odd, is there something obvious? Okay, let's consider one connectivity component. If there is a leaf vertex, then I simply have to put these two vertices in different parts. So I can remove this vertex, then I solve the problem. Ah, I got it. So the answer is always 2 because I can do it recursively. I can remove the vertex of odd power, then everything of odd degree. Then I solve it for everything else recursively, and then I return my vertex v. Okay, how can I do it fast? Somehow. Yeah, somehow. Okay. Still, it will be like this. Okay, so first of all, I always calculate the all degrees. Then if then all even are false. Yeah, after that. Okay, for now, let's do like this. So assume that it is not all even. So if all even, I simply return 1 and VIN. Otherwise, the answer will be 2 and the division. And how do I do it? Okay, for the recursion, let's have like vector booleans of all active vertices. Then I find any vertex of odd power, of odd degree. I remove it, then I solve it recursively for this part. Then I return it and solve. Okay, let's make the recursive function. So okay, vi answer equals find answer recursive for what? I have n, I have actually I believe we need to store this degree thing. And also I think we will need adjacency lists. Okay, so here we do the following. We say like this, say g p.x pushback p.y, vice versa. So here we put g dig and active vertices. And active vertices is n of size true of size n. Okay, and here we just return 2 and ans. Let's write this function. So at first it's like same. I go through all vertices. And if g active I and degree of I is even. Actually, I can do it without any recursion. Yeah, I can do it with a cycle. Let's do it with a cycle. So while true, let's do the same thing. First of all, I start with a hypothesis that everything is even. If this is odd and the vertex is active, I say that it is false. And let's also find the odd vertex. Okay, so here, if they are all even, no, I should have recursion. Should I? Okay, maybe not, but we need vector ints of, how it's called? It's called postpone. If all even, then I simply break, and then I consider all postponed vertices. Otherwise, I need to say the following. I need to say that I postpone the vertex I, not I, but odd vertex. Then I go through G odd vertex, and if and simply say that minus minus diag. And active of odd vertex equals false. Yeah, it seems correct. Okay, now now all vertices which are still active have even degree. And then I put them in the zeroth basket. Now I need to put some vertices in the first basket. Okay, while postponed dot size, what I do, I say that int v equals postponed dot back, then postponed dot pop back. In the end, I will say that active v is again true. Then I go through all its neighbors. G of odd vertex. Not odd vertex, it's just v. So if it is already active, then I say that plus plus d. No, if it is active and it is... Let's say that if ans I, actually. If ans I, this definitely means that it is already active. Okay, so if d is odd, this means that among the active vertices and in the first basket, it has odd number of neighbors. So actually I'm not interested in it, I want an even vertex. So if I have an even degree, then I have to say that ans I equals ans v equals 1. Then active equals true, and in the end return ans. Okay, let's see. Okay, a lot of ones, and here we have 2, 2, 2, and 1, 1, 1. 2, 2, 2, and 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, 1, 1. 1, But it's not correct because for vertex 3, the degree is odd, isn't it? Ah, oh my god. Because it is not correct at all. It's not correct at all? Okay, I have already made up two solutions which are false. So if I have a vertex which is odd vertex, I cannot simply remove it from the graph, because now I hope that its neighbors are even this time. Okay, what do I have in terms of linear algebra? In terms of linear algebra, let's assume that initially I have all vertices in the left basket. In this case, this means that I have some odd and even numbers here. So each time I have something here and something here. Each time I put a vertex from one place to the other place, all neighbors here are removed and all neighbors here are added. So actually I simply add its adjacency list to this adjacency, like not matrix but row. I add it here. Great, so the question is, can I make all zeros using these separations? I should be able to do it. I should be able to do it. The problem is I also have, so for example, if this is the ith, it's not exactly adjacency matrix, because also I have here the parity of the vertex itself. So on the main diagonal also has the parities of all vertices. And this means that the sum of all rows is 0. The sum of all rows is 0. And this means that they are definitely not linearly independent. So the question, I have some symmetric binary matrix with sum of all rows 0. I want to choose several rows that if I have the initial vector equal to this main diagonal, and I want to represent it as sum of several rows here. Is it always possible? Not really sure about that. Can I have some strange graph? What about this graph? Okay, this graph, for this graph, it's definitely not possible. Yeah, because for this graph, like if I want to put this vertex into the first part, then I need to put this vertex in the second part. No, it works. I need to do it like this. Okay, it's something strange. Okay, let's try to formulate it in terms of matrices again. So I have some matrix, and let's assume that it is zeros here. So it's just a simple adjacency matrix, A. So we know that A equals A transposed. The second thing that we know is that let's construct it with ones on this diagonal. Yeah, so we can take A times all ones. So we can multiply it by matrix of all ones. What do we get? We get the matrix, or even just by a column of all ones, just with a column. And we get a column which consists of parities of each degree. So let's call it D. Let's call it D small, and then D capital is a matrix where there are zeros here, and D put like this. Okay, now I have A plus D, and I want to multiply it by some x such that I get D, and to get D. That's what I want. Correct? Okay, what is D times x? D times x is the following operation. I have this row D, I multiply it by x, and so it is like element-wise multiplication. Let's call it like point with circle. Okay, so I want to find such a vector x such that ax plus d times x equals d. So is it always possible? I even don't know if it's possible or not. So we can component-wise multiplication. It's not really component-wise multiplication because, so what I want this matrix. I want here x1 times d1, here I want x2 times d2, etc. Here I want xn times dn. Is it possible to find such a matrix? I think it should be possible. But how? In order to do that, no, I really need this. I really need this to do it. Oh. Well, I can simply find this matrix, but why does the answer always exist? Or ignore this question? So assume that I ignore this question. Is it just a bitwise Gauss? So I simply have some matrix, and I want to multiply it by some vector to get some other matrix. This is simply a Gauss, isn't it? Okay, let's do it. I have a matrix. It's really strange. Fine, fine. Let's hope that it always exists, and I just don't understand why. So we have some square matrix. We multiply it by x, and we need to get some column. To do that, we just make the Gauss. So how it's done? It's done like I put this column here as one extra column. And now I want what I want to do. Well, I want to diagonalize. Not diagonalize, but make a trapezoid matrix like this. Then I check that here I only have zeros. Then I just find necessary values. Okay, maybe it's fine, maybe not. So how do I make this diagonalization? Make the diagonalization, I store it as bit sets. Okay, assume that this is already fine. I have some spent columns. Now I have still some non-spent columns. And I always ignore this last column, which is nth. So I find any non-zero element here. I put this equation here. Then I add this to the list of non-spent columns. And after that, I need to go through all other rows and XOR with this row if needed. Okay. So it's called pair bool VB bool Gauss, which is VB A VB D and that's it. So how do we do it? First of all, we make some bit sets. Bit sets should be of size 2001. Now we go through, we make like vector of bit sets, which is our current matrix of size n. Okay, we have constructed it. Now we need to make the Gauss. How do we perform the Gauss? Perform the Gauss. We try to find any unit. Okay, I really like to have a find first. Okay, here it is. So okay, I need some custom invocation. Mm, okay, it says 8 if there is no find first. Okay. So here we just return t dot find first. Else we return, we go through. Okay, like let's replace it with n. Size t, it should be size t. For int I equals 0, I less than n plus plus I, if ti return I return n, and if great. So we go through int I equals 0, I less than n plus plus I. So what do we do? Let's look at BI. So int And first, while true, we take B. Let's actually go from last one to the first one. So we take while like B dot size is greater than I, like this. So we take B dot back. We take its first non-zero digit. It's written like find first of B dot back. Okay, if f is n, this means that we have a problem because our system does not have a solution. So we return false and VB of n does not have a solution. If f is n plus 1, then we return, then we simply pop back. Say b dot pop back. Okay, otherwise, no, not n plus 1, but n, capital N. Let's write like this. If it is greater than n, we pop back. Okay, now we assume that it doesn't have any. It has 1, so we break. So if is at most I, then we need to break also. What do we do otherwise? We swap bi and b dot back. Now we have bi. Let's again find first of this digit. So now, what do we do? We have ith row and some column, which is called f. We go through all other columns. And if bji, then we need to XOR. Say bj XOR equals bi. Great. Then we stop. Then we continue our Gauss. Okay, now when we have done it, the system definitely has a solution, because if it hadn't, we would return here. It has a solution. Moreover, I'd like to store all these numbers. Let me think. Okay, actually, I think we need to start from 0 here. So if I is not j and this, then XOR. Why is that? Because I don't want any ones here, so they should be replaced with zeros. So actually, if we have a 1 on this line, it is the only one in the whole column. Yeah. After that, it should be simple dimple. I store so chosen is the numbers of columns. Chosen dot pushback of f. And here I go through all chosen columns, and I say that wait, first of all, VB ans of size n. I say that ans of chosen of I is ans is what? Is bin, then return answer. Return true and answer. Okay, now it should work. Okay, I have written my Gauss. Now I need to return remove this, all of this. Okay, what do I do here? I check all degrees. I'm not sure I need this at all. Yeah, I don't need G. Let's simply construct the matrix. And I say that matrix p dot x, p dot y is true. Matrix p dot y, p dot x is true. After that, go through all this, and I say that MII is true. So this is the construction of this matrix A. Let's also put it into D. If all even, I return 1 bin. Otherwise, I need outer exists ans equals Gauss of M and E. Not M and E, M and D. Then full Gauss. Okay, now it should work. Okay, this is weird. Okay, 2 1 1 1 1 1. Okay, maybe we can just submit it and it's fine. However, I have some doubts. So let's stress it. So how do we stress such thing? create a test, we solve it. Okay, also, if not exists, let's throw 1. Or I don't know, let's just return. Let's just not do anything at all. So great test. Then we put this test. Then we need to check it. Then if not verdict, we print test, preprint the test. Mm-hmm. It's impossible. Mm-hmm. And now we need to check it. So how do we check? We need to consider all edges in test. We each all inner edges. So we consider vi degree of size n. We take test dot first. We consider degree n, and we go through all edges. Actually, first of all, we need to check ans, that it only has numbers from 0 to n. So if ans I is less than 0 or ans I is at least r, then we break. We return false ans out of bounds. If ans.size is not n, we return false incorrect size of ans. For int I pip from test.y, if ans p.x equals ans p.y, plus dec px plus dec py. If dec I %2, then return false order vertex. Turn true. Then we can go. Yeah. Okay, it seems fine. It seems fine. I don't know. Maybe we can submit it after all. No? Rock answer test 3. Why? Ah, oh no. I ignored it. It is bad. It is bad that I run the stress, but I didn't notice that it does something. Sad. If there is a huge graph for which there is an odd vertex for some reason. Let's make it smaller. Okay, here we have an odd vertex. So for this matrix it said 1, 1, 0, and of course there is an odd vertex. Actually, both 1 and 2 are odd vertices. Let's see why it happened. Hmm. Mm-hmm. First of all, let's look if it exists. Yeah, it exists. So we have a bool Gauss. Of what kind? B is empty. Okay, this is sad. Why is it empty? Ah, D. True, false, true. It looks like 0, 0, 1. No, 1, 1, 0. 1, 1, 0. 1, 1, 0, 1, 0, 1. And 0, 1, 1. What? Why? Okay, it is understandable. So initially we have what? We have 1, 0, 1. And we want to make some operations. Namely, we want to choose this row and this row. Or this column and this column. Doesn't matter. So that in total we get this column. Yes, it is correct. Why did we fail to solve it? This test? I don't know. So let's look at B. Somehow. So we look at the first row. Swapped it with at the last row. And we swapped it with the first one. So now we should have 0, 1, 1, 1, 0, 1, 0, 1, 1, and here we should have 1, 0, 1. No, 1, 1, 0. Then we found the first non-zero bit, which is 1. Yes. Now we push back 1 to the chosen. Yes. Then we go through all rows such that bji is true. Bjf, of course, it should be f here. Oh, it's sad. Okay, now stress for 3 works. What about stress for a bigger number? Okay, now it should work. Time limit? No, not time limit. Why still New Year? New Year magic is over. Okay, now I definitely need to choose the problem wisely because I'm not going to solve all 3 problems, I think. This is a hard mathematics, actually. This is a hard mathematics. Okay. Problem C. Forest fires. So we have a fire. Is it true that there is a tree in each point? Yes, in each cell there is a tree. So we have some huge thing. We have several trees. And after what? After t seconds, we have some sort of this thingy. Great. Ah, by angle also. So no. Of course it looks like squares, not rhombuses. And we need to find some strange sum. Okay, I don't have any idea how to find it, so let's go on. Problem D, GCD of polynomials. We have two polynomials. Then polynomial A can be represented this way. A is b times d plus r, of course. Since there is a way to divide polynomials with remainder, we can define Euclid's algorithm of finding the greatest common divisor of two polynomials. It takes two polynomials. Yes. This algorithm works in finite number of steps. You are given an integer n, you have to build two polynomials with degrees not greater than n, such that their coefficients are integers not exceeding y by absolute value. The leading coefficients are equal to 1, and the described Euclid's algorithm works exactly n steps. Okay, this is interesting. This is interesting. I kinda don't understand why we just don't take the random polynomials. It should work for random ones, I believe. Yes? It should work for random polynomials. Maybe not, maybe not. Maybe this shouldn't work for random polynomials. Okay, we can do it backwards easily. We can do it backwards. So in the end, we have something like 1 and 0. Before that, we have 1 and what? Okay, let's assume that we at some moment have p of degree k and q of degree. The problem is we need to have coefficients of zeros and ones. Mm. 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 If that's it, That is nasty. So this is a constructive problem. $150. What? Let's see. So the last polynomial will be 1 and a lot of zeros. Before that, I don't know. There are cases. Okay, doesn't matter. Let's assume that something like this. Okay, before that we have something like this. Okay, before that we have something like this. No, what do we have here? Actually, here I can have any plus minus 1 that I want, and here I can always also have any plus minus 1 that I want. Let's assume that that's this one, for example. Then I need to have here 1. Okay, I'd like to have here minus 1 and here 0, so that I just add it here and get 1 here. Yes? Yes. Okay, so I believe it looks like this. I have a lot of, on the odd places, I have zeros and ones. This is the odd places. And on the even places, no, doesn't look like it should work like this. Maybe something Fenwick-like. Maybe something Fenwick-like. Yeah? Maybe something like this. No, these two seem a bit suspicious. These two seem a bit suspicious. It shouldn't be like in Fenwick. So I always should have a constant term here. Let's continue maybe. So what do I want to get this polynomial? I want something like 1 0 1 0 1. Yes, I want something like this. So how do I get it here? Okay, I need to have something like this so that I subtract this row and I get what I needed. Okay, let's try and write some brute force. Okay, solve test. Int and number n Here we have pair vi, find ans of n. How do I solve something like this? I just need a static. Okay, static bvi answers if answers dot empty. Okay, the answer is at most 150. Let's just say that answers equals construct answers of 150. Then I return answers n and answers n minus 1. Let's construct answers. I create the initial answers, then I need something like construct recursive of answers and n. So how do I try to do it? So assume that I have some last vector and one but last vector. So what do I try to put here? So this is like Pn minus 1, this is Pn, and this is Pn my plus 1. What do I try to do? What do I try to do? I try, first of all, I try Pn plus 1. It should be Pn minus 1 plus Pn times something. And the question is, what is something? It seems that I need to try x minus x, x plus 1, minus x plus 1, x minus 1, minus x minus 1. These 6 polynomials. This is what seems reasonable. Let's try them. So I have PVI mult, actually static PVI mult equals 0, 1, 0 minus 1, 1, 1, minus 1, 1, 1 minus 1, I mean, minus 1, 1, minus 1, minus 1. For PIM from mult, I try to take VI poly equals, okay, actually n plus 2, and actually 2, and ansys 1 equals 1. And here I need n plus 1 and n. So I try poly equals ansys dot size minus 2, and poly equals sum of poly and product of ansys dot back and m. Okay, and if good poly, then I try if good poly, then I try to push back poly, and if it is good after the pushback, then I return true. Else I pop back. Now I need to write the function sum and prod and good. Let's start with good. I go through all numbers, and if I is less than minus 1 or I is greater than 1, then I return false, else I return true. Now we need vi sum of vi a and vi b. What do we do here? Let's assume that actually the first thing is of greater power than this, of greater degree than the second one. So this is greater than this. Okay, in this case, I simply need to try just adding all coefficients of b. And finally, vi prod. ans I plus j plus equals ai times bj. Turnouts. Nice. Also, let's make static int y equals 0. Here we say that y is, if answers dot size is greater than y, then y equals answers dot size, and we print a y, and then we go. Let's see. It failed because answers was not big enough. Ah, again, it is a bit empty and still not understandable why. Ah, here I need return false actually. If it didn't work, then it didn't work. Stack Overflow? Seriously? What? How it's possible? Ah, okay. So easily? Really so easy? Okay, I won't mess with this, but let's look at how it happened. Let's look, for example, at 50. 50 didn't work? Ah, okay. Here I need to remove this thing, and here I need to write like this. Okay, it somehow works. I really don't know what it does, but let's try to submit this. Ah. Okay, since it is a wrong answer test 3, let's look at test 3. So we multiply it by x and we add it. I don't understand. What? The leading coefficient should be equal to 1. Okay, this is a mistake. How can I make the leading coefficients equal to 1? It seems that I always can simply multiply it by -1 if needed. Can I do it? Let's think. If I multiply... Okay, let's prove that if I multiply 1 or 2 elements of GCD of Euclid algorithm by -1, then everything suffers the same change. So assume that here I multiply a by -1. Okay, so here b is same, and a mod b. What happens with a mod b? Seems like it also replaces with minus a mod b. Now let's assume that I change b. Yeah, actually, yeah. Correct. Okay, let's write a function sign which, given this array, changes its sign. So if v dot back is less than 0, then for int I from v, I equals -i, return v. Now it should be fine. Wrong file. Excellent. Excellent. Okay, among these two problems, B and C, I mostly like B, so maybe that's what I need to try and solve. And C will be a nice dessert for me. Okay, we have a game. We have a long row of carrots, and the first player wants to maximize the residual one, and the second player wants to minimize the residual one. They play the game one by one, and what happens if they play optimally, actually? Okay, first of all, I'd like to notice that the game massively depends on the parity of the last player. For example, if I have something like this, then no matter what happens during the game, the answer is determined by the last player. So their last player has two things, and they decide which of them will be in the answer. So let's actually solve this problem differently for even axis and odd axis, because the problem for these numbers is vastly different. Okay, let's assume that the last one is, who are they? Oleg and Oleg and who is the next? Igor. Oleg and Igor. Igor wants to minimize the juiciness. And we only need to print the numbers here. Okay, let's look at the Eiger's process and Oleg's process. So if Oleg moves last, he just chooses maximum among these two numbers. So when there are three numbers, Eiger wants to minimize this maximum or this maximum. So we may assume that he simply removes the biggest of these two numbers. So Eiger's function is like maximum of A2 and minimum of A1 and A3. So this is what happens when Eiger takes some array. Now we have Oleg. So Oleg wants to maximize this number. So if he wants, he can always choose one of these two numbers, but he can never choose one of these numbers. Okay, because if he wants to choose any of these numbers, actually he can choose minimum of them. Can't he? So Oleg always can choose any of these numbers, but if some of these is bigger than any of these, then Eiger destroys them. Hmm. 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 Okay. Is it true that Eiger can, for example, if we have some array, Eiger can just guarantee that the answer is maximum of these two numbers, of two middle numbers? First of all, Eiger can easily make anything but them to disappear. He can just remove all these numbers and all these numbers. Moreover, he can do it by a symmetric strategy. So let's think what I'm talking about. I'm talking about, so let's assume that Eiger moves. First of all, Eiger last move is taken by Oleg. And for example, the first move is also taken by Oleg. This means that the number of moves is odd, and this means that the initial length is even. In this case, I guarantee that Eiger can make the answer maximum of these two numbers. How? This is a symmetric strategy. Whatever Oleg does, Eiger makes the corresponding move from the other side. Okay, yes. Whatever Oleg does, Eiger moves from the other side. However, Oleg also can guarantee the maximum of these two numbers because he can make the symmetric strategy. For example, let's assume that this number is maximum, then he just always takes from the farthest side from this maximum, and he wins. So if Oleg moves first, then the answer is this maximum. If Eiger moves first, then he chooses which of these two maxima he wants, and he goes into it. Okay, the same way we can prove that if Eiger is the last, then the answer is minimum of the medium two numbers. Now let's think about Oleg. So Oleg wants to maximize the answer. He wants the answer to be as big as possible, but he can make first several moves. Okay, this means that he simply wants to, let's just take the medium elements, and he tries to make he just, let's take some big element and he wants it to be in the middle. Actually, this is what happens. We take some big element and he wants it to be in the middle. So if it is possible, he puts it into the middle, otherwise he doesn't. Okay, the second case is, okay, I understand. When Iger moves last, this means that Oleg wants to choose two neighboring elements which are what? He wants to choose two neighboring elements which are as near as possible. Of two neighboring elements whose minimum is as big as possible. And to put them in the middle. Yes, so we understand how to solve this beautiful problem. Solve test. What about, yeah, no multitest. So we have this one, solve test, n, the array. If now we have findance, vi findance of vector. Okay, const int n equals v dot size, and we have vi ans of size n. Okay, let's go. First of all, I'd like it to be okay. 0 is fine, I think. Let's go through all numbers. N is at least 1. N is at least 1. Okay, first of all, let's say that ans.back is simply the maximum in the array. So this is easy. Everything else depends on the pair. So assume that Oleg wants some pair to be in the middle. So for example, I and I plus 1. He wants it to be in the middle. There are two cases. I and I plus 1. he wants them to be in the middle. So in the beginning, he wants to remove so how many elements he needs to remove? He either needs, like, there are I elements here and n minus I minus 1 elements here. Yeah? No? No, n minus I minus 2, because this is n plus second element and this I plus second element and this is nth element. So he needs to remove obs of n minus 2I minus 2 elements. So to remove equals n minus obs n minus 2I minus 2 elements. Okay, let's assume that he removed them. Now they are in the center. So now if he moves the first, if he moves the first, then the answer is maximum of these two numbers. So if he removed this number of elements, then he gets maximum of these two elements. And if he now moves Eiger, and Eiger moves if to remove is greater than 1, is at least 1, and ans to remove minus 1 is maximum of ans to remove minus 1, and since now Eiger moves, then it is minimum of Vi and Vi plus 1. Okay. After that, in the end, we need after that, in the end, we need to update all the answers. To do that, we simply say that from 2 to n, say that ans I is max of ans I and ans I minus 2. That's it. Copy, paste, copy, paste. And also I want one more test, even two more tests. Even three more tests. Three, 3, 5, 5. A lot of billions. Oh, here it's interesting. Here it is interesting. So the last number is always the maximum, yeah? Okay, if Oleg removed everything but one, also always two last elements are maxima. But three last elements are not, because if Oleg has to remove everything but three elements, then he removes one more element, so he leaves two elements, which is 1 and 9, and Eiger removes 9. Yeah, I believe this is correct. Yeah? Is it correct? Oh my god. Why? Okay, the question is, I think, the following solution. What if we have like 6, 1, 1, 10, 10, 1, 1? So it says that the answer for 1 is 1. But I think that it is incorrect. So first move that Oleg does is this one. Then he always also makes this move. Then Igor removes this, Oleg removes this. Igor removes one of these. I don't get it. Why it said that the answer is 1 here? Okay, maybe I need to write it like this. So else, if to remove +1 is less than n, then +1. Yeah. Okay, I have several minutes. 50 minutes? 50? 50 is a lot. I have 50 minutes for problem C. However, I hate problem C. But I have 50 minutes for problem C. Okay. Okay, this is fine. This problem is fine, actually. To solve this problem, let's make the following subproblem. Given big square, let's assume that it's the only one. Actually, here is what I want to look at. Let's look at 2 points and let's make them how it's called, disseminate, spread. Actually, it's called the spread. So they spread, and at some moment they touch, don't they? So they touch at some point. What does it mean? This means that now it will continue like this, and it will continue. Oh, what I am interested in is what is the shape of like middle perpendicular between them. The set of points for which the distance is same. Let's think about it. So again, I have 2 points. I have 2 points. Let's put them like this. So what is the set of points for which the distances are the same? Okay, definitely it's something like this. Also, seems like it's something like this here on this picture. But what about something? So what about this picture? Here we actually okay, I just need to look at them. Let's look at them. So for example, here is 0. Here is also 0. So these points are 1s, and these points are 1s, then these are 2s, and these also are 2s. Then here we have 3s, and here we have also 3s. And now these two will be marked x's because they have the same distance. Now these are the 4s, and these are the 4s. Then these are the 4s, and then this is 5, this is 5, and this is x. This is x, and this is 5. Okay, now I hate it because it seems unreasonably hard. So will it continue to look like this in the infinity? So like, is there some sort of point? It seems like there is. So there should be a point such that this distance is the same as this distance. Hmm. So if we have 2 points, then what? Let's draw their middle perpendicular. Let's draw the middle perpendicular. Let's draw this 45 degrees line and this 45 degrees line. Then this is the part of their middle perpendicular, and then it goes like this. Here it goes like this. Yes? Yes. So what I'd like is I'd like to have a rectangle where only one of these possibilities happens. Yeah, because if I have only something like this, it is easier. So I will have a solution in like some huge logarithm. Okay, let's try and do something. This is a problem. This is a problem. N and T. N and T. Then VPI V of N. Yes, then we print find ans of V and T. Okay. We simply find ans of what? Okay, since all coordinates are between minus 10 to the 8 and 8 to the 8, 10 to the 8, and t is at most 10 to the 8, then everything interesting lies between 2 times e to the 8, 2 times 10 to the 8, and minus 2 times 10 to the 8, 8 2 times 10 to the 8. And v and t. How can we solve such a problem? Actually, let's change it a bit more. Okay, no, fine. So let's look at the rectangle. We're interested in how many rectangles are there which somehow change its answer. to do that, we can simply find the nearest point to this rectangle. I get it. We need to find the nearest point of each of the corners. Let's find the nearest point for each of the corners. And if there are at least 3 different... No. It doesn't work like this. Let's find the nearest point for each of the corners. I got it. So let's iterate over all possible points. For each point, let's find the nearest point to it. For example, it's here. I think that this means that you cannot... If there are some other point which is nearer, then you don't mind if you just remove this point from consideration. And we hope that we are only left with 2 points. So if we're only left with 2 points, we are fine. Yeah, however, it's possible that we are left with more than 2 points. And if we are left with more than 2 points, we need to divide even more. Yes? Yeah, don't exactly like it, but maybe it's fine. Okay. So what I don't like is if we divide it into 4 parts, maybe this recursion will take a lot and we will have tail. I hope it won't happen, but it's really hard to analyze it. Intuitively, if we have 3 points, for example, then the only problem is if we have Android. The only problem is something like this, the point where all 3 distances are the same. So if I leave somewhere here, so I have some big rectangle and divide it into 4 parts, and 3 of them will be fine. So the only problem is this part, which is not fine. Okay, let's assume that it's fine. Now we have a rectangle and we have 2 points. We need to solve it. I believe we need to divide our space into 9 rectangles, which look like this. This, this, and this. And we need to solve the problem in each of them. Okay, so let's assume that our rectangle is here, for example. Oh, I hate it. How can I solve it if it's inside this rectangle? There are a lot of cases, fortunately. Okay, let's consider the easier cases. For example, here. Here we always have actually I don't understand it. So let's consider 2 small cases. Okay, the first small case is something like this. For example, 0 and 0. Okay, in this case, do we actually need to rotate it 45 degrees to solve this problem? I feel like we might need to do it. I feel like we might need to multiply or to rotate it 45 degrees. Because the perpendiculars will look more nicer. Okay, let's rotate it. So now a circle has this shape. Okay, let's consider the first moment then when 2 circles touch. And also let's assume that each 2 points have the same sum of has an even sum of coordinates. Okay, in this case, actually when they touch, the first time they touch by some part of border, which looks like this. After that, I think it looks like this. So here we have the same sum of coordinates as here. then it goes up, and it goes down. Okay. Okay. Okay, actually I need to rotate it 45 degrees. Okay, in this case, there are two hard parts. So the first hard part is if I'm here, somewhere here. And the second hard part is if I'm somewhere here. No, if I'm somewhere here. So this is the hard part. So I need to understand that I am only under influence of these 2 points. However, I am under influence of these 2 points only. It's still calculatable because I'm somewhere here. Okay, let's try and do it. I don't think I will do it in time, but let's try. So let's rotate 45 degrees. So we have this. So here we say that Wi equals Vi minus Vj and Vi plus Vj. Then we return find ans recursively. Okay, so after this operation, first of all for each 2 points, their sum of coordinates is even, and their difference of coordinates is even. This is the first thing. The second thing is now all coordinates are between -2 times this and 2 times this. And t equals also 2 times this. So we need like 4e8 and 4e8. Wt. Okay, so again, we have a rectangle, and inside we have several points like this. Okay. So for each point, hmm. Hmm. Okay, so let's reduce this VPI doubling. So we go through all. What do we do? Hmm. Okay. Okay, we look at this point and we need to check if it has any use at all. So let's find the nearest point. So int x equals max of x0 and min of x1 and v I dot x, and the same thing for y. Okay, we found the point nearest. Then we need to check, is it true that it is nearer than anything else? Let's say that, let's find the distance actually. So So we go through okay. If distance between z and vi is at most distance between z and v and p, then we say that useful is false and break. After that, if not useful, then we erase vi. Great. So first of all, we removed everything from v which is not needed. After that, if v.size is at least 3, then we need to divide. Also, let's do something like this. So if x0 is greater than x1 or y0 is greater than y1, then return 0. So we here return int xm equals x0 plus x1 over 2, ym equals y0 plus 1 y1 over 2, and we return find ans rec x0 xm y0 ym vt plus, not plus, but sum of this and this modular m, where m is this number, and some other number. And here we have ym plus 1 y1, and here we also have ym plus 1 y1. And int sum should be calculated as, actually, since we have only one constant modulus, let's make sum of two arguments. Great. So now we need to calculate the answer if we only have impact of two different points, or maybe one. If one, it's really easy, but what if we have 2 points? Okay, let's assume that they look like this. So this is, actually can move the picture so that it lies in 0, 0, and it lies somewhere in the first quadrant. And I have some rectangle. So what does it look like? It looks like if we have something like this, then the picture looks like the distance of this distance equals this distance. The question is, will there be such a point? The answer is yes, because if this is x and y and this is... Actually, no, it's not guaranteed. It can be half integer point. It can be a half integer point. So I need such a point that delta x here equals... No, it exists. It's not true that it should be like exactly 45 degrees. It can be, for example, here. Here. Yeah. Yeah, this point exists. It definitely exists. So I need to find these 2 points. It's not hard. I can find them. Definitely. Okay, what do I do then? Okay, so if I have a rectangle which is fully to the left of this line or to the right of this line, this is easy. Actually, what if they're exactly 45 degrees? Is it true that then it looks like this? Here, and then here, and then here. And why does it not look like this? Maybe it doesn't look like this? I hate tropical geometry actually, because I don't understand it. Okay, maybe this is a corner case, and usually it looks like this. And even here, I may assume that it looks like the right picture. So I can swap coordinates and I can rotate the picture so that it looks like this. So here, 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 and here. So this is how my picture looks like. And I want to consider some rectangle. So first of all, I may assume that a rectangle lies here or here, so it doesn't intersect this line. So if it fully lies in this part or in this part, this is easy because I can write some function which does it. So let's assume that it intersects this thing, but it still lies in this area. What do I do then? Then I need to consider this part and this part. Oh, this is awful. This is really awful. Okay, in this case, I can say that this is, I can find these points of intersection and actually make this division and find this plus this plus this. And here it is symmetric. So actually it should be easier to find because it is symmetric. Yeah, let's try and do it. First of all, if what do I do? What do I do? If x0 is at most if v dot empty, I don't know how it happened, but okay, let's return 0. I even can do it here. So if x0 is at most v0 dot x, but x1 is greater than v0 dot x, then we return sum of find ans rec of x0 v0 dot x y0 y1 vt, not v, v, yeah, and this. Okay, v0 dot x. So if for 1 this happened and v dot size is at least 2, then I do it for 1. Then I repeat the same process for y's. Okay, now it does not intersect these lines, but it might intersect these lines still. Okay, so how to find this line? Actually, how to find this line? How to find this line? Hmm. Okay, let's do something about this. If v dot size is at least 2, actually it should be 2 now exactly. Let's do something about this. Okay, if v0 dot x is greater than v1 dot x, then I need to inverse all x coordinates. How do I do it? I say that v0 dot x is minus v0 dot x, v1 dot x is minus v1 dot x. Then I return find ans rec of minus x1 minus x0, y0, y1, v10. After that, the same about y's. After that, if v0 dot y minus v0 dot v1 dot y minus v1 dot y minus v0 dot y is greater than v1 dot x minus v0 dot x. This means that I would like to rotate to make a reflection. I swap v0 dot x and v0 dot y. I swap v1 dot x and v1 dot y, and I return this with swapped coordinates. Okay, now it looks like this, definitely. So yeah, it looks like this. So now if it is to the left of this line, I'm fine. If it is to the right of this line, I'm fine. Also, it might be here or here. So now there are like, so this is not interesting, this is not interesting, this is not interesting. And the same for this. So the question is what happens here? So I can be here or here or here. So if I am here, let's think about it. So this is definitely the 0 point, and this is definitely the first point. Actually, I'd like it to be here, I think. Okay, so if we okay, I got it. I want to consider this line. Okay, yeah, it was obvious. So we are upsolving now. If we consider this line, I want to be either to the left of it or to the right of it. So how can I be to the left of it or to the right of it? I need firstly to find this line, and it is not hard. It is something like x0 plus. So I need this point to be halfway from here to here. So let it be z. And I want the following. I want y1 plus z should be 1/2 of x0 plus y0 plus y1 plus x1 over 2. Then z is x0 plus y0 plus x1 minus 1 y1 over 2. Great. Okay, so if y0 is at least v1 dot y, then I'd like to make a division by this coordinate. So I say int q equals v0 dot x plus v0 dot y plus v1 dot x minus v1 dot y over 2. And I divide by this q. So here I have, no, I should copy this one. x0 q plus 1. No. Also, if q is, let me think. Actually, I don't want so strict restrictions. Let's do it like this. So if q is less than x0 or q is greater than x, if q is greater than x0 and q is less than x1, then I return this. Great. Then okay, I remembered something. So here actually I need to say that dist between z and p, let's actually find it firstly. Here I use d, and d should be at most 2 times t. And if not useful, then I immediately break. And now I can check about v.empty. If v.empty, then also return 0. Also the same thing about if y is if this yeah, and if y1 is at most v0.y, then we are here, and we can also make the division by this line. And since we can, let's do it. This time it should be minus here and plus here. Yes, we did it. So now the only problem is here. We want to understand what we do with this square. So as far as I understand, we need to check if we intersect this line. How do we check if we intersect this line? We simply need to ask about this point and about this point. Oh my god. Okay, int half sum equals v0.x plus v0.y plus v1.x plus v1.y over 2. This is this line. So if x0 plus y0 is strictly less than half sum and x1 plus y1, it definitely should. It definitely should be. Let's like check that it's always true. It is less than half sum and this is greater than half sum. If it's not true, then let's throw something. Okay. Now it intersects this line. Actually, I want only to do it if y0 is at least this and y1 is at most this. We live in this area and we want this to be here and this here. Then we want to find where this line intersects our rectangle. Oh, and I don't like it. Let's try and do it. How do we do it? Let's look at this point, for example. So, if x0 plus y1 is greater than half sum, then we would like to make a separation. How do we do a separation? we say that int ym equals y0 plus like half sum minus x0, I think. Yeah, and we divide it. Mm-hmm. Okay, else. No, not else, but if x0 plus y1 is less than half sum, then we want to divide it like this. So we need xm is half sum minus y1. We return this. Great. Now the same thing about lower part. Yes. So let's swap. So now we have x1 plus y0 is greater than half sum. Then we need ym equals half sum minus x1. Let's see. So this point is greater than half sum. This means that we need to subtract y0 here. And here we have x1 plus y0 is less than half sum. This means that we have something like this intersection, and we need to subtract x1. Yeah, great. So now we have either, so if still this v dot size is at least 2, then we need to check that if x0 plus y1 equals half sum, if it is not true, or this is not true, then we need to throw, because it is impossible. Actually, it should be at least 2, because we are here. So I can write it. Great. So now I have a question. So how to solve for this thing? It shouldn't be hard. It shouldn't be hard. What I need is actually to so I need to know this number. I need to know this number, and I need to know actually this is a square, so I just need to find this. So this is defined by this number and this number. Yeah. How to find it? And it's awful because it also depends on the parities of A and B. So it's like A, then A plus 2, a plus 2, then 5 times a plus 4, let's start with the following. I have some diagonal which maybe consists of a not one but maybe 2 times. So I know the number of a's and I know how many times they're there. So it's like sum of I jumping by 2 and starting with some I0. So I have a plus I times I. Till some number b. First of all, let's consider it as there is some upper bound. God. We have this number, which is an initial number. This is jumping by 2. And I calculate this thing. And also I need to divide it by something. Yeah, actually it jumps by 1. So this should be halved. This should be halved. Actually, I can divide by 2 in the end, so let's not think much about it. Let's divide by 2 in the end. Now I just calculate the answer. Okay, so let's rewrite it as with integer i's, I think, because otherwise it's just impossible. So I jump by 1. Okay, I jump by 1. I have something like this. But it's not correct because here I don't jump by 1. It's actually, maybe it's 2i plus 1. Is it true that I always need some cases? It is sad if I always need to use cases. Okay, let's jump by 2. Fine. Let's jump by 2. If I find I0, I jump by 2. Ah, I got it. Let's consider I equals 0. I jump by 1. And here I need to stop when, so it is like 2i plus I plus j, some j. And here it's also 2i. Great, let's rewrite it. It's 2aj plus 2i times a plus j plus 4i squared. Okay, assume that there is some big number j here in the end. Or j minus 1. Okay, let's consider j. Then it is j plus 1 aj, I, big I plus 1 aj, plus I plus 1 a plus j, plus this thing till I, which is simply I plus 1 to I plus 1 times 2 divided by 3. Okay, excellent. Simply excellent. So what is a square function? We have some value a, which is in the corner of the square. Then we have some value b, which is on the diagonal of the square. And we need to calculate it for only even values. So for that, we need to consider this progression. This progression, this arithmetic sequence, it starts with, we need to find the first value which appears. So if a%2 is 0, then we have an even number. Yeah? So the corner is an even number. And we say that I0 is 1. And it's always j here, I think. We should always use j here. So it is 2j here. And this is a plus j here. So a0 is always a minus 1. Great. So we can rewrite it as I0 equals a%2 plus 1. Okay, what about this main diagonal? We need to question ourselves, what do we use for this big I? So we want the first moment that a plus 2I plus j is b. Yes? So I0 is this value. So I0 is b minus j minus a over 2. And I1 is even less than it. Then I need to sum two progressions, which is So I need this formula. So big I is actually positive, always positive. So I can take let's think how to find 1/3. To find 1/3, I need to find the residue of this number, which is, so this is divisible by 3, this is also, so this is 2 modulo 3. So I need to take m plus 1 over 3. This is 1/3. Okay, here I need to first of all, product of I and product of I plus 1 and 2I plus 1 and product of this by 2 and product of this by third. Okay, this is S3. So also I have S1 and S2. S2 is calculated as I times I plus 1 . Okay, this is tricky because A plus J should be okay, A is always positive, isn't it? Yeah, it's always positive, so simply product of I and product of I plus 1 and A plus 2J. And finally S1, which is what? I plus 1 times A plus J times J. And finally I return the sum of all numbers. Great, now we have considered the square. So the square is considered. Now we only need to consider everything else, which is not much actually. So now we have the following problem. We have a rectangle which is fully in this rhombus, and we need to find it. Moreover, as far as I understand, we already did I can repeat actually this thing. So after all, And now let's move it into the positive part. So if actually if v dot size is at least 2, then let's throw 0. If y0 is less than v0 dot y, then let's invert everything. If x is less, then we also invert everything. Great, now it is in positive part, so it is here. And in this case, how do we calculate this beautiful sum? Actually, this sum is not very beautiful. Unfortunately, this sum is not very beautiful. Oh my god. I hate this problem so much. Okay, let's think about this sum. First of all, if the sum of these coordinates is odd, then I can replace it with the sum of this rectangle and this rectangle. And actually, let's do it. So if x0 plus... Actually, I just want to make all numbers even. Can I do that? I think I can do that. Let's make all numbers even. So if x0% 2 is not 0, no, there is a problem. I can't do it. I can't always do it. Let's start with what I said. So if x0 plus y0% 2, if it is odd, then I replace it with two rectangles. So x0 plus 1 x1 y0 y1, yeah. And x0 x0 y1 y0 plus 1 y1. The same for ones. So if this, then I take y0 y1 y1 Oh, x1, x1. y0, y1 minus 1. Yeah, what happens here? I remove this column. I say that this point does not exist at all, so I just consider this thingy. Yeah? I consider this thing. Hmm. Okay, I know what I would like. I would like here to be able to have negative eyes. Namely, not here, but maybe here. Okay, so I'd like to have here negative eyes sometimes. This is because if I have a rectangle, then this looks like this part, which is solved by function prog. But this is also solved by this function prog. But for now, I cannot do it because this is a decreasing sequence. So here I need to sometimes subtract I. So let's write it as this and this. Okay. Okay, let's do it. Then this A times J plus and maybe minus. So it's like AJ plus minus J squared. So maybe here is minus. Okay. Next. What about this thing? This thing comes from 2I times J okay, here it should be plus J and then plus minus J. And finally it should be plus minus this thing. Crazy, but let's do it. So there is a coefficient. So now, first of all, I calculate product of coefficient and this thing. Also in S2, instead of this, I need to consider sum of this and product of J and coef modulo M. And finally here, I need to consider sum of A and sum of and product of J and coef. Yes. So now I'm able to decrease, to go down. Okay, let's not do it. I don't think we really need it. Let's consider our rectangle. It consists of three parts. First part is here. The second part is here, and the third part is here. Let's look at them one by one. So the first part let's look at S1. So how do we calculate it? We have this sum and we have this sum. Also there is this thing which looks like this. Yes, so we need to find first of all A0 is this minus 1, I think. So let's actually subtract everything from. So let's say the following. I want to say that x0 minus equals I got it. I got it. I can make it more easier. So how to make it more easy? First of all, let's say that x0 minus equals v0 dot x. I don't need const here. No, let's do it as this. So if okay, first of all, if v0 dot x is not 0 or v0 dot y is not 0, then I need to subtract everything. Return find ansrec after subtraction. So x0 minus v0x, x1 minus v0x, y0 minus v0y, y1 minus v0y. Nice. Then if x0 is greater than 0, then I return the following. I say that it is difference actually of two things. Oh my god. I understood something. Actually here I don't have the right to go until B. I need to go until T. So here I need to say that it is I'm a bit dying now. I don't think I can get a working prototype. I'm not sure I can get a working prototype at all. diff1f. This is called math. Thank you for calling this math, but this is not math. This is puke. Not awesome. Not awesome. 198, guys. Guys, this is not normal. Why are you solving this? You're a great person. Why are you solving this problem? Go solve normal problems. What is this? I'm speechless. This problem shouldn't exist. Okay, let's see what... Maybe I am just overcomplicating things. Maybe this problem is actually easy. There is clear, nice solution. But since it's Technocup, I really doubt it. I think this is an awful problem for people with strong hands, which I am not. Ah, 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 ah. Some pen and paper work. Yes. Yes. How much time did it take? 30 minutes. Yes. 30 minutes is fine. Let's solve everything in 30 minutes. 30 minutes. 35 minutes, yes. It's 35 minutes. Yeah, it's problem for 35 minutes, definitely. Definitely. Okay. Here it's not a huge problem. It's not a huge problem because why? because here I can choose minimum of b and t. Here I can write minimum of b minus 1 and t. Great. So this is kind of working. This is kind of not. What do we do here? Hmm. Okay, this is fine. Let's do this. Optimization. Here I say that I calculate some difference. Here I can calculate the difference. No, here it's fine, but here so now I assume that it is both zeros. So if x0 is greater than 0, then I find answer recursively, which is x0, x1, y0, y1. But here I say that I need difference of this and this. And here I need the difference for y. So now we have this starting point, and we have this rectangle which starts here. We need to find its function. Let's do it. So first of all, we need to find this thing, number 1. Number 1. How do we calculate the thing number 1? Let's find the number which is written on this diagonal. It's something like b. Okay, I think we need to put 2t here. For the sake of this problem, t is double t. Okay, so I need to find the number. Actually, again, let's make it like this. So if it is like this, I can swap its sides. Okay, if y1 is greater than x1, I swap everything. Okay, I swapped everything. Now it looks like this. Now we have three parts. In this part, my function is from 0 to y1. So this is y1 here. So I need to take the prog of what? I start with -1 actually. I start with -1. Then I have j. What is j? J is 1. Then I is how many I need to add. So like if this is 0 and I added 0 times, then what is this diagonal? This diagonal means that I need to add y1 over 2 times, I think. So it should be y1 over 2. But if it is greater than t, then I don't need to do it. So minimum of t of y1 over 2. And finally the coefficient, which is 1. So I don't do it. Okay, let's find answer 2. Answer 2 is everything which happens from this to this side. Everything what happens here. How do I calculate it? It's actually only even numbers in this parallelogram. So let's find this side of the parallelogram, this side of parallelogram, and find everything. So this side of the parallelogram is y1 plus 1 over 2 times 2, which is simply y1 like this, like this. Okay. This is x1, so this side of the parallelogram is let's put it like this. So I need to take x1 minus 1 over 2. No, I don't think so. I think we need to capture this side as well. So let's capture this side as well. So it's x1 over 2 times 2. Okay. And the number of numbers on each diagonal is y1 plus 1. So y1 plus 1 times the sum of this progression, which is left plus right times r minus left plus r minus left over 2 plus 1 divided by 2. And also I need to stop at moment t. Okay, so let's say that int L equals y over 2 times 2 plus 1. Int R equals minimum of t and x1 over 2 times 2. This is 0. And if R is at least L, actually this is incorrect. This is totally incorrect because it should be plus 2 here in this point. Then S2 equals product of y1 plus 1 and something. Okay, also I need to create a half, which is easier. Actually, I didn't need it because here it's definitely an even number. So I have L plus R over 2 as the first thing, and R minus L minus 2 over 2 as the second thing. Yes, this is S2. And this is the sum in this parallelogram. Okay, finally, let's look at the number R plus 2. S3 equals 0. Then I say that if R is at least T, is at most T, then I need to do something with S3. So R is at least T, and I find this sum. It's again a progression, which can be calculated with my function. Coefficient will be m minus 1 in the end, because it decreases from the corner to the middle part. Let's think about these three numbers, a, j, and I. Let's start with a. A should be 1 less than this angle. One more, I think one more than this angle. So int a equals x1 plus y1 plus 1. So this is a. Now j. J is the first moment, the first diagonal which is taken. So what is the first diagonal which is taken? So I have x1 plus y1. First of all, if it is an even number, if this is an odd number, I need to subtract 1. Also, if it is greater than t, then I just take t. Now let's think how this affects. So I0 is simply the number of numbers on the first diagonal. What is the number of the numbers on the first diagonal? It looks like it is a minus mx. Okay, finally let's find I. What is I? To find I need to find the minimum number which is taken. This is, I think it is R. So I is mx minus R over 2. So either in the perfect world this should work. However, we are in a much worse world, so it won't work first million attempts. Oh. Technocup. Okay, we have infinite recursion. Let's find out what happened. So it was always the case that y0 was less than this number, but y1 was bigger than this number. Here it should have been 0, 0. Of course. So the first bug eliminated. Okay, now we have some other bug. Stack overflow. Let's look again. Okay, we definitely have a problem because x0 equals x1 and y0 equals y1. And v is of size 3, which shouldn't have happened. Let's check what is the meaning of all of this. So now we have all zeros. Also, so I want to stop if here we have x0 equals y0 and x1 equals y1, and v dot size is at least 2. This is my condition, which should not hold, definitely. Let's look here. Why didn't it change? Why everything was considered useful? Ah, because it should be here. Now it makes sense a bit, just a bit. It's still not correct at all. At least it makes some minimum sense. Actually, I need to divide the answer by 2 in the end. Let's do it, actually, right now. I need to divide it by 2. Now it should make more sense than it did. Okay, this should be the easiest thing because it simply means that one of my function is incorrect. Because it shouldn't be 140. Okay, let's do it. So we want to jump here. See what it says. So now it's x all zeros. Why it's all zeros? And v equals also 0, 0. It definitely should be all zeros in S. Yes, it did. Are there any other answers? Yeah. Yeah, there it is. Stop, what? Why did it ask about 0, 0? And what was y? 1? Okay, doesn't matter. Okay, now we have this strange... How this happened? Okay, fine, whatever. T is 4. And look, it looks like this. So we have 0, 1, 1, 1, 1. Actually, 2, 2, 2, 2. 2, 2. And then 4. A lot of 4s. And we are asking the question about this infinite region. In this infinite region, the answer should be 20 plus 12, which is 32. Let's firstly just check that it is 32. No, it's immediately 140 in this segment, which it shouldn't be. Okay, let's see. So minus 1, j, I, coef. Let's fix what this function calculates. So I want to say that it always calculates sum of I equals 0 to capital I of what? Of a plus 2I plus j times actually c, if c is coef, then minus 2ci plus 2ci times 2I plus j, and that's it. So this is what this function calculates. Let's check that it does what it needed to do for minus 1, 1, 4. Ah, 4. It shouldn't be 4. It should be divided by 2. So here we needed to what? Yeah, we need to divide by 2 after this. And conversely, here we need to divide by 2. What? What? Mm-hmm. 26. Now it's too little, because it shouldn't be 26. Okay, now it says that this thing is 26, but it should be 32. No, it's still not correct. Minus 1, 1, 2, coef. Minus 1, 1, 2, and coef is 1. So let's see what it says. It says that I need to take minus 1 plus 1 plus 0 times something. Doesn't matter. Then minus 1 plus 1 plus 2 times 3. 2I plus j, yes. And then minus 1 plus 1 plus 4 times 5, which is 20. So this is 20. This is... Ah, this is 6. Yeah, it's 26. Correct. This is correct. Yeah, 26. Great. We get the correct answer. This is definitely 26. Which should be divided by 2 in the end. So the reason I see here 26 is that the exact answer is 52 actually. Let's understand now why all of this happened. So this is the correct answer. 26 is the correct answer. So here 26 is also correct answer. So what is the question here? Here the question is beginning with y0 equals 1. Okay, this is because the answer with... Let's go here. What? Yeah, what about this thing? Here it is all zeros. However, it's not correct. Why it is not correct? Because it should be something like 0 plus 2 plus 4 equals 6. So it should be 6, and it should be 6 because of the parallelogram part. So let's look at the parallelogram part. So let's look at L and R. L is 2, R is 6, so yes, it should be something like this. 1 times 4 is 4. No. What? Why isn't it divisible by 3? Why is R 6? R shouldn't be 6. Ah, I get it. So, okay, let's fix that we want 0 this, 0 this. I think we can. Yeah. So now R is 4. Ah, this is because here we had -2, and this messed up with everything. Let's see why it messed up. Because of this. Yeah, because it should have been +2 here. $24. Why is it 20? 20 is really not enough. It doesn't make sense. These zeros resulted in 0. This resulted in 26. Yes. Now this resulted in 6, which I like. This resulted in 26. This resulted in 26. This resulted in 26. This resulted in 6. 26. 26. 0. 6. 2. Why is this 2? Okay, this is not fine. Why is this 2? Why is R... What? Here we have a problem. Why is R2? It is... Why T is 2? Because I have the next test? Okay, let's ban all tests except this one. Okay, we banned all tests except this one. This is fine. Okay, all functions returned the correct answer. This means that what was incorrect is the recursion steps. Okay, so for example, here we have a difference between answer for a stripe and for a rect and 0. Just the difference of stripe and 0. And this is just stripe, so this is 6. Yeah? Great. So let's see. So 20 is answer where? It's answer from 20 is answer in the rectangle 0 infinity 1 infinity. Is it true? It is the answer. So the answer here is 20. Yes, it is 20. So I agree. Okay, now here, we're here. Here it is between 1 and infinity, and again 1 and infinity. So it calculated answer 2 incorrectly. So here answer 2 is incorrect. 0, 0, 1 infinity is incorrect. Zero, zero, one infinity. So it thinks that it is 26, while it isn't. Here it is. A sneaky bug. Now it's 40. 48, 0. So this is not 8. This should be 18. Let's make an easier test. I think this is too hard. Let's make a test where we have these two cells and this. So the answer should be 10. How do we do it? We simply say that we want 4, we want 1, we want 2 and 1, 0, 0, 1, 0. And we are asking about the answer 10. No, it says it is 8. Let's fix this. Again. Let's look at some answer. Okay, from what? How did it happen? Ah, I think it's about... Okay, fine, whatever. So here the answer is 6. No, let's again choose 1 here. So it's 6 when in this rectangle it's 6. Seriously, it's 3. Ah. Okay, after changing everything, it looks like this and this. Yeah, and now it's like this. So now when we start here, it is 6, yes. Okay, something else? Okay, if we only consider a stripe, then the answer is 2. And it is 2. If we consider stripe, the answer is 2. When we consider nothing, the answer is nothing. When we consider everything, the answer is 6. 2. 6. 2. 6. And it's ended. Why is it 8? Okay. Oh. So what happened? It said that since so it wants to divide into one infinity minus infinity infinity. Actually, it doesn't work well. It doesn't work well because it thinks that this is a useless point. This is because I needed to write like this here. Now it's 10. Interesting. Now it's 10. 14, 18, 0. Do we believe that it's now fine? I think it is the wrong answer, but let's submit because I'm tired. It's an exhausting problem. Runtime error on test 7. Possible to know why is runtime error test 7. Let's absolve it in the Technocup. Still? I still don't know. Exit code is 3. Okay, I think it's simply some recursion thing. So let's make a stress. Great. Great. No. What? V is M. Ah, V dot size is still at least 2 and V through. V through here. And the question is why V dot size is at least 2? Because it shouldn't have happened. So we didn't consider some case. Okay, let's draw it somehow. So we have point. Let's draw axis first of all. This one and this one. Okay, this is X, this is Y. Okay. Now let's consider the rectangle. It is from -3, 0 to -1, 2. Okay, this is this square. Great. Then let's consider our cities. Cities are in point -4, -2. And in the point 1, 3. Okay, this is definitely the case where we consider this perpendicular. So the perpendicular looks like this. Here, then here. And here it goes like this and then this. I'm trying to calculate this answer. For some reason, it didn't understand that we have a square. So we should have stopped. Okay, let's make it here. Ah, we didn't calculate the answer for the square. Stand it. So here we needed to calculate the answer. But we didn't. So we need to say that int answer is something and then return answer. How do we return the answer? We say that it is just square of what? Of x0 plus y0 half sum t. Funny. Okay, now at least it never fails. Now at least it never fails. Let's check that it gives the correct answer. I believe I need something like this. So what is the answer in this test? 16. Is it 16? So 0, 4, 1. Yes, it is 16. What about 2 here? 64. Why is it 64? It's 8 here, and 2's into this figure. Okay, first of all, let's get at least one wrong answer, or no? No, let's not get a wrong answer. Let's first try to calculate it. So 1, 2, 3, 4, 5, 4, 4, 3, 4, 4, 3. 8 plus 7, 15. 15 plus 12 is 29. 58 plus 8. It should be 66, doesn't it? Why 64? Ah. Again, 0, 0. 1, 1, 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1, 1, 1, 1. Okay, now 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54. For some reason I bugged. It is actually 54 here. So it should have been 27 here, not 29. Yes, it is 27 indeed. So still 54 plus 16 results in 70, not 64. Can we make an smaller experiment? So 0, 0, 2, 0. 13. The correct answer is not 13. Or is it? Correct answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, it is 13. This is not 64. This is not 64. Okay, let's draw this picture how it will look like after the transformation. After the transformation, we will have 0, 4, 4. We will have some numbers. Numbers will be 2, 2, 2, 2, 2, 2, 2, 2. 2, 2, 2, 2, 2, 2, 2, 2. 4. I mean, 4, 4, 4, 4, 4, 4, 4, 4. No, not like this. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. 4. Yes. And all 4s here also. A lot of 4s here. Four, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Okay, we need this test. We needed to answer 64. I think it shouldn't work on some square, so the answer is incorrect for a square. This is what I think. So this should fail some moment. So it says that something is 4. Let's look at what is 4. 4 is answer for 0044 and the square 1313. It says it's 4 for 1313. Let's see. 1 3 1 3. So the answer is definitely much more than 4. Should be 20. No, it should be 16. It should be 16 because it's 4 plus 4 plus 4 plus 2 plus 2. However, it says that the answer is 4, which is much less. We condemn such behavior and we need to check this function. So it says it's 2, 4, 4. One, 1, hmm? 70. Now it's 70. But did we change our function correctly? So let's think about it. We have a square with this number a and this number b. Let's think. We have two parts. this part and this part. This part is like this. So here we say that a0 is definitely a minus 1. This is fine. This is the number which, so if we add 1, we still get a. Now we need an arithmetic progression, and we need to find its length. Its length is the last minus first divided by 2 plus 1. This is the length. And we don't take plus 1, we just need this fraction. So the last number is b or t. Yeah, the first number is a or a plus 1, which is to say we can write it like a% 2. Why not? So yes. Okay, now this part. This part is the same, but we here have b minus 1 and we need to end here. And it seems like we end here. Okay, it's 70. Let's upsolve again. Let's try upsolving again. So I don't run stress always. Need to upsolve this problem. Now it's wrong answer, test 7. Is it because of this function? Do we want to stress this? Oh my god. We definitely really want to stress this. Hmm. So I have written a stress. Let's check it. What does it say? Hmm. Okay, it found a test. Let's try to make it smaller. Make it smaller. Let's first try to use n equals 1. However, I think it will work with n equals 1. And let's try. So if n equals 1, still no. What? This is because I need Chebyshev dist, not Manhattan dist. So let's find Chebyshev dist, which is return maximum of abs of a dot x minus b dot x and minimum actually, maximum. Maximum abs of a dot y minus b dot y. Now it works fast. Works fast. Now let's. What is. Here, let's now put 2. Here, let's put 1 and x will be 1. It also works. What about 2? Okay, now it failed. So it should be a really simple test. So I have 2 points, 1, 2, and 0 minus 2. 1, 2, and 0 minus 2. Yeah, and it says that the correct answer is 12. Well, it's... Yeah, I shouldn't have written 12. I don't know why I wrote this. Let's rotate the axis. Now it is here. The first point is here. The second point is here, where this is 3, 2, 1, 0, minus 1, minus 2, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. XY. Okay, let's explore this test. Let's make an investigation. So I remove the stress. I put 1 here. And I want to understand why it is so strange. Let's look at the square part. Maybe we have a square. Or I don't know. I really don't know. Okay, it really asks about some square. What? Ah, I didn't copy this test. Yeah. And now minus 2, 0, 0, 2. Minus 2, 0, 0, 2. So minus 2, 0, 0, 2. Ah, what are the points? The points are... No, I can't draw it in the same axis system. Let's draw it in this axis system. So here the points are minus 3, minus 1, and 2, 2. These are the points. Kinda makes sense? Does it make sense at all? Yeah, it makes sense. Now what is the square? Minus 2, 0, 0, 2. The square is this one. And t is 1. So t is 1, so I have 1. So t is 2 actually. T is 2. Is t2? Yes, t is equal to 2. So I have 2 and 2. The answer should be 4. But is it 4? No, it is negative. Let's look into this function. 1 and 0. So it's negative even for this half for some reason. For some reason it's negative here. Ah, I needed to subtract. So it works only if v is 0. v0 is at 0. So I needed to subtract v0.x minus v0.y, and I always need to subtract it. Yeah, so let's replace with this. Now it gave 16 correctly. Okay, let's now return the stress. Now it's more correct than it was before. Let's now increase everything. No. Unfortunately, life isn't as easy as expected. Let's try put 5 here. It definitely nothing. So let's put 1, but now let's put here 2. Okay, let's now put 20 and 10. Let's now put 2 and 2. Let's put 2 and 3. Okay, 2 and 3. Wow. Okay. Oh. Now we have the following test. -3, 1. And 3 minus 2. Correct answer. Something and I have something. Again, this seems like it should be the square function which does bad job here. Let's actually just see what happens with this square function. Because maybe it causes the problems. Okay, so we have the following query. We have two v's, which is -3, -1, and 3, 3. Here it is. And -2, 0. And 1, 3. So this is our square. What is half sum? Half sum is 1. So it seems like this looks like this. Okay, whatever. 2, 4, 4, 6. What? They don't intersect. They don't intersect. This is just 6, and this is just 6. Yeah, let's look into this function, which is 2, 5. Ah, yes, 5. 2, 4, 4. No, 2, 4, 4, 4. And here we also have 2, 4, 4, 4. Okay, what is the answer? Could you please remind me what is the answer? The answer is 28. So in the 1/2 it's 14. But it's correct. It's correct. It should be 14. Okay, there is one more. What am I doing? Okay, of course we have completely new query. Okay, so -4 -2 5 1. -4 -2. And 5 1. Yes, and we have x0. It's kind of small square. It is here. No, it's not here. -1 0. 0 -1. And 1 0. This is here. So the answer is 12. But we get 24. I don't like it. I don't like it. Interesting. And now it is -1, of course. Answer is 0. It is definitely great. Okay, just in case, what if I say here that if I is less than 0, then I return 0. Oh, everything's the same. Infinite errors. Immediately? Okay, immediately. Well, maybe we can just look at the square. Maybe we can just look at the square. I'm so tight that I can't even find this function square and where it's run. Okay, it should be somewhere here. Yeah. Yeah, let's see. We have... Let me just remove everything from here. Okay, let's start with this rectangle. It is -2, -4. -1, -3. This is our rectangle. Now let's look at my points. -3, -5, 1, -3. Okay. So it's an easy 4, isn't it? It's an easy 4. And it's set 4. Okay, maybe something else? Did I stop the stress? Oh my god. Oh my god. Why am I doing this again? Minus 6 minus 2. Four, 2. Nice. Nice. Then we have the rectangle. Rectangle is minus 2 minus 1. 0, 1. Let's see what are the answers. So first of all, t equals what? T equals 3. Yes, so the answer should be 24. The answer is 24. Are there any other squares? 226? What's the problem? It is 24. But the correct answer is 2 less. Just in case, can I subtract just in case? Still, okay. But the problem is not with the function square for some reason. So when I run this function, it's fine. I only run this function once, and when I run it, it gives 24, which is fine. What? Okay, let's look at something else. Okay, so now we have the following rectangle. We have minus 2, 4, minus 1, 1. What? Minus 2, minus 4. Ah, minus 2, minus 1. 4, 1. So we have this rectangle. The answer in it is 26. It should be 26. Let's look what it exactly is. 2, 2. 4, 4, 4. 6. It seems like a 22, doesn't it? 4, 8, 12, 16, 22. Why 26? So this function is incorrect. But why? And why is v big? 1, 4 minus 1, 1. 1, 4 minus 1, 1. What? And v is still minus 6 minus 2. Why didn't we eliminate the first thing? Yeah, we eliminated it. So why 0? Let's now look at our answer. It seems like it says that we start a new coordinate axis here. We draw a rectangle 0, 1, 3, 3. So it shouldn't be 22. It definitely is not 22 at all. Y0 is greater than 0, so I find two answers which are bigger and the smaller one. So let's start with easier one. It says that this is 28 for some reason. This is 28. What? Why is it 28? It cannot be 28. It's too small for it. Okay, so let's see. There are 3 parts: S1, S2, and S3. S1 is 6. It is simply... Yes, I understand what it is. Now, S3 is 22 for some reason, while it should be 18. This is not correct. 7, 1, 1 coefficient. This is minus 4. Sum of some squares is minus 4. What? Ah, because it's multiplied by 4. Seven, 1, 1, minus 1. Seven, 1, 1, minus 1. What does it mean? It means that I start with 7 here. I start with 1, so it's 6. It's 6 here. The next one is what? Ah, it's I. It's like I need after that 3/4. And minus 1. So it fails for some reason. Okay. Okay, formally it should be 7 plus 1. So j should be minus 1 instead of 1. Ah, because it should be cj here. It should be cj here. Yeah? It should be cj. Let's check that it is correct. Now, it should be now 6 times 1 and 4 times 3. This is 12. This is 6. It's 18. And 18 would be a correct answer. Let's rewrite it again once more. So this is... Let's start with the constant term. A plus cj times j. Yes, a plus cj times j times I plus 1. Yes. Now let's look at the terms with exactly one I. This is 2i times a plus cj plus 2i plus j. No, plus j. And finally plus 4c times I squared. Okay, 3 terms. Let's start with this one. This should be 4 and minus 4, and it is minus 4. Next is S2. S2 is this strange part. It should be 2 times 7. 2 times 7, 14. Yes. Finally, this term should be 6. It's 6 times I plus 1. So it's 12. So it's 12 plus 14 minus 4, which is 20. Incredible. What? I found it. Found it because I forgot to multiply this 2ci by this j. Didn't I? So 2I is multiplied by a plus cj and cj again, actually. So instead of this, I should have written like this. Good. Good. Oh. How it's called? It is called guys, it is called some accurate pen and paper work. I added the word accurate because if it's inaccurate, you see what happens. Just a bit of pen and paper work. Just a bit of them. Some old good pen and old good paper. Sorry, paper. Old good paper and old good pen. Hmm? Why so slow? Yeah, let's increase something. 5, 15, 15. Pen and paperwork. Pen and paperwork, just a little of it.